it's me again. I'm Lena and I'm from the Healthcare Landscape Group. In this video, I'm going to be talking about my third day edition, which is on my D3 week 76. So this day edition is basically on medication dosages, solution measurements, reporting health statistics, treatments, medical imaging, research, etc. So those are the main focuses in this week's DE3. Now in this video, I'm going to be talking about the problems that Mrs. Pratt sent out for us to do based on these topics. So let's get started on the first problem. Now Mrs. Pratt only gave us spaces so that and also the topics that we can base on to have the examples ourselves. So this is the example that I came up for the first problem. The first problem is on dosage calculations. So I chose weight-based dosage calculations. The order is 0.4 micrograms per kilogram per dose. So the weight of the patient, my patient, is 23 kilograms. Since he or she is only a child and my dream is to become a pediatric child, so I think that it's a good idea to implement it into this video as well. So how do I do this problem? Well, since the patient is at his or her basic form of kilograms, we will be able to do the multiplication. So we will just take the order times the patient's weight, and we will have the dose, the amount of dose, which is 9.2 micrograms per dose. And yeah, that is my answer for problem number 1. Problem number 2. Problem number 2 says that Mrs. Pratt said that we need to calculate the input intake, fluid intake, and the output monitoring. So firstly, for the fluid intake, I have this list of this timeline that the patient take in. Firstly, the patient took in at 8 a.m. 8 ounces of orange juice and 6 ounces of yogurt. At 10 a.m., 8 ounces of coffee with 1 ounce of cream. At 11 a.m., 12 ounces of soda and 12 ounces popsicles, and then 4 ounce broth. Next we have the 1 p.m., which is 6 ounces of soda, and finally at 2 p.m. they had an 8 ounce ice chips. So there's fluid only, no solids. And we see that in this whole list, there's only one solid food, that is yogurt. It's not actually solid, it's a mixture between both solid and liquid, but the solid part is more than the liquid part, so we consider it as a solid. So we will eliminate that out. Now for this specific problem, for the fluid intake, we will only calculate the amount of fluid that is taken in. And this needs to be in a simplified form in milliliters. One way that we can do it is add all the ounces together and then multiply by 30 to turn it into milliliters, or we can take all of this and transform them into milliliters individually, and then we will have the final result. So there is one trick here. There are 2 12 ounces ice popsicles. What does that mean? Well, there are 2 12 fluid popsicles, so 2 popsicles. So each one is 12 ounces. So two of these 12 ounces is 24 ounces. So that is one thing that we had to consider. And then all of these things added together, we will have 2,130 milliliters of fluid intake. So that is the total amount of intake that my patient took in for one day. And yeah, that is the fluid intake. For the output monitoring, a patient had TURP which is a kind of like procedure in which he or she needs to needs to have problems with his or her bladder. So a patient had TURP and is receiving continuous bladder irrigation. During your 12-hour shift, the patient fully collects the tube and the bag collects 5,320 milliliters total of water and urine combined. The patient received 2,500 milliliters of bladder irrigation. What's the patient's urinary output? So the problem is asking for the amount of urine that the patient got out. But we know that the total amount of urine and water combined is 5,320, and the patient received 2,500 milliliters of bladder irrigation, which is water, not urine. So it's very easy. We take the total amount minus the 2,500 milliliters of water, and we will have the milliliters of urine, the amount of urine output, which is 2,820 milliliters of urine. So that is for problem number 2, the fluid intake and the output monitoring. For problem number 3 is measuring blood pressure, heart rate, and oxygen levels. So I have this example of a normal adult and an abnormal person with a heart rate, blood pressure, and also oxygen levels, I think. And so for the blood pressure is actually, let me come back to the board. The blood pressure is actually the pressure that the blood is forcing onto the walls of our veins. And so the normal amount, let's put it here, BP. The normal amount is less than 120 over 80 millimeters of mercury. So this is the element of mercury, just a symbol for the element of mercury on the periodic table. And yeah, that is for the blood pressure. So why is it in fraction form? Well, this needs to be less than 120 and also less than 80 millimeters of mercury. So yeah, that is the normal amount of the blood pressure in a person. So let's take, for example, 100 over 75 millimeters of mercury. So that is a normal person with normal heartbeat. Next we have heart rate. Heart rate, for the normal heart rate is from 60 to 100 beats per minute. So a normal person will maybe have 65 or 80 beats per minute. So yeah, that is the normal amount for a normal adult. And also the oxygen levels. The oxygen levels between 95 and 100% is a normal person. Anywhere under that amount is we need to see a doctor immediately or have special care. So let's say 98% of oxygen levels, O2, is a normal person. But what about an abnormal person? Well, an abnormal person will have anywhere under or above that range. So let's say, for example, a person with a heartbeat of 130 over 90 millimeters of mercury, and his or her heart rate is 120 beats per minute. and also its oxygen levels is 78% oxygen. So yeah, that is an abnormal person. Let me write it here. Abnormal person. Maybe he or her, maybe that person may have like disease and a disease, or is unhealthy and just obese, and yeah, that is a very important thing to consider, because this affects our health and our overall well-being. So that is all for my video. So for the first problem, I don't exactly know how to do the fourth problem, because there is like the math problems, the math concepts are very advanced. For each one there's very advanced formulas, and I am not able to understand them, so I'm not able to do that problem. But if you guys can help me out with the fourth problem, it would be glad for you to help me. I would be glad for you to help me. Thank you again for listening to my video. That is all that I have to say for this video, and I'm looking forward soon to see you in the next video or the next meeting. Goodbye, see you later.